One somewhat difficult concept for people to understand is power. I'm going to start off with an example for power to attempt to explain it. A new medication that claims to improve typing ability is currently being tested. The average person types at 30 words per minute with a standard deviation of 16. The medication is expected to increase average words per minute typed to 46. A sample of 16 individuals is taken to determine if the medication actually does improve typing ability. So we're going to go ahead and assume that the medication works and really does increase words per minute to 46. What is the probability of us correctly concluding this with our statistical test? Basically, I'm saying, okay, we know the medication works, and we're going to say that the null hypothesis is false and the alternative is true. What's the chance of us correctly determining this with a test? So the null hypothesis is that the mean is 30, and the alternative is that it's different from 30. So we're going to assume the medication works, so we're going to automatically assume that the alternative, which I'm pointing to, is true, and that the null is incorrect, that the null is false. So power is our probability of correctly rejecting the null hypothesis, and beta is the probability of us incorrectly retaining the null hypothesis. So we're going to do this question using an alpha of 0.05. Now first of all, I'm going to calculate standard error so I know how to properly plot this on a distribution. I've talked about standard error before. It's just standard deviation divided by the square root of your sample size, and in this case we find a standard error of 4. So I have a distribution here where the mean is 30 and the standard error is 4. As you can see, it goes from 30 to 34 to 38 and 30 to 26 to 22. There's a distance of 4 between those numbers that marks the standard error. This is the distribution if the null hypothesis is true. And remember, we're using an alpha level of 0.05. So those numbers I have marked there, negative 1.96 and positive 1.96, we would expect 95% of the values to fall between those two values and the other 5% to fall outside of those two values. So I have another distribution that I've drawn to the right. Now these two distributions are not really affecting each other in any way. I'm just showing you the two distributions side by side so you can see how they're related to one another. This distribution that I've drawn over here is the distribution if the null hypothesis is false. That is, we're actually saying the alternative is true. We're saying that the mean is 46 with the standard error of 4. So in this distribution on the right, you can see that the mean is 46 and the standard error is 4. It still goes from 46 to 50 to 54. There is a distance of 4. So let's say we are using, we're going to do a test and we're just using the regular null if the null hypothesis is true distribution. So anything that is above 1.96, that means we're going to reject the null hypothesis because it falls outside of that 95%. If it's within that 95%, that blue area I have marked, that means we're going to retain the null hypothesis. So given that the null hypothesis is actually false, you can see that there is a large orange area. If the distribution is actually over there, then there's a very good chance that we're going to end up rejecting the null hypothesis and saying that, oh, okay, so it actually did increase average WPM to 46. This orange area is our power. Remember, power is our probability of making the correct decision, correctly rejecting the null hypothesis when the null hypothesis is false. And anything left over is the type 2 error. So what we need to do now is calculate what exactly the probabilities are for power and for type 2 error, or beta. So I'm going to move that up, and now we need to know what number in the distribution on the right is associated with 1.96. So first of all, what I'm going to do is find out, okay, I'm going to multiply the standard error by 1.96. 1.96 is how many standard errors we are from the mean. So 1.96 times the standard error of 4 is 7.84. That means we're 7.84 above the original mean of 30. So that means that value exists. 1.96 exists at the value of 37.84. So we can put that right there. And now that we know that it's 37.84, we can use that number to calculate what probabilities are associated with power and type 2 error. So first we're going to calculate the z-score. Now we're using the distribution on the right. We're going to take 37.84 minus the mean of 46 divided by the standard error of 4. And we're going to find out that the 1.96 from the distribution on the left is the same as negative 2.04 in the distribution to the right. So now in order to find the area in the body, I'm going to go to a z-table and I'm going to look up 2.04. And when I look up 2.04, it says that the area in the body is 0.9793. 0.9793 is the power. So it's about 98%, and anything that's left over, 1 minus 0.9793, that 2% is the type 2 error. So there, our power, our 98%, means there's a 98% chance that we will correctly reject the null hypothesis, meaning we will reject the null hypothesis when we're supposed to reject it. And the type 2 error is the chance that we will not reject the null hypothesis when we actually should be rejecting it. So that is power, and that is the type 2 error, which is also called beta.